Okay, here in this video, we're going to look at a couple of quadratic applications, some word problems involving quadratics. Most of our problems with quadratics will involve optimization, finding a maximum value or a minimum value. In fact, in college algebra, if a question says, find the maximum area, find the minimum cost, if you see the words maximum or minimum, you're probably dealing with a quadratic and you're looking for the vertex. Finding a maximum or minimum always means find the vertex. And hey, it's a good thing we know how to find the vertex of a quadratic. Now, a lot of times you'll have to do more work than that. You'll have to set the function equal to 0, find some x-intercepts, maybe some y-intercepts. But at some point, you're going to be finding a vertex, pretty much every time. Okay, my favorite application is the projectile problem. People throwing stuff up in the air and watching it fall, or rockets, or anything that goes up and comes back down is going to follow a quadratic. And we're always going to be maximizing that, looking for some maximum height. Okay, so here we've got Dave throwing a ball off a building. We're given a formula for the height of the ball. T here is measured in seconds. That's our time after Dave throws the ball. And S is measured in feet. That's the height, T seconds after he throws it. And we're going to answer 3 separate questions. We'll find the maximum height. We'll find the amount of time it takes to reach the max height. And how long it takes for the ball to hit the ground. So parts A and B together here. That's the vertex. Remember, vertex is a point, not a number, an x and a y. I don't have x and y here. I have t, time, and I have height, s. So the time is playing the role of x in vertex. Remember, vertex is h, comma, k. H here will be a time. That will be part B. And then K, the y value of the vertex, will be the maximum height. That'll be part A. So we're actually going to solve part B here before we solve part A. These questions are usually worded like this. You got to be on the lookout for that. Okay, so that maximum height, that's the vertex. Remember our formula for vertex. First we find h, the x, t in this case. Coordinate, opposite of b over twice a. Here b is positive 32, so the opposite of b is negative 32. A is negative 16, so twice that is negative 32. We get 1. We're halfway done. That's half of the vertex. To find the other half, we take that number we just got and plug it back into the function. So k is s of 1. You can check these details. You do get 144. Now we have to interpret these numbers. What did we just find? Remember, that first thing you find, h, is your x. We don't have x's. We have t's instead. So that's a t value. That 1 is a t. T was measured in seconds, time. K here is the y value. In this case, s of t, the height. So this is not 1 foot and 144 seconds. That would be ridiculous. We're on the top of a building. There's no way the maximum height is 1 foot. And there's no way it takes 2.5 minutes to get there. 1 was the time, 144 was the height. So the maximum height is 144 feet. It takes 1 second to reach that. We just found the vertex. Okay, the other part, hitting the ground. When does the ball hit the ground? The typical mistake people make here is they want to just plug in 0. They want to plug in t equals 0. T is time. I don't want to know what the height is at 0 seconds. I already know that. That's the height of the building. I want to know how long does it take until the height is 0. So I set the height equal to 0. Set the function itself equal to 0. Here's my function. I set it equal to 0. Height is 0 feet. Okay, now I picked nice pretty numbers here. So this will end up factoring. But what if it didn't factor? Well, then completing the square always works. Quadratic formula always works. We know 4 different ways for solving quadratics. In this particular case, this guy will factor, but no matter what, you always know how to solve this. Okay, so first off, everything here has a common factor of 16. So I divided through by negative 16. I like having a positive leading coefficient. I don't want this negative in front. So divide everything by negative 16. We get t squared minus 2t minus 8 equals 0. You can check those details. Hey, that factors. That's t minus 4 times t plus 2. Check that. Make sure you believe that. Now I have two things multiplied together to equal 0. What does that mean? One of them must be 0. So either t minus 4 equals 0, which gets me t equals 4, or t plus 2 equals 0, which gets me t equals negative 2. One of these answers doesn't make any sense. We're talking about time here, time after Dave throws the ball. So negative 2 seconds is 2 seconds before he throws the ball, when he's still climbing the stairs or he's standing up on the roof. He's not throwing the ball yet. The ball's not moving. It's in his hand. That time makes no sense. Throw that away. It's not part of our reasonable domain for this question. T equals 4 makes perfect sense though. It takes 4 seconds for the ball to go up, come back down, and hit the ground. So sometimes you can have negative time. In this application, negative time doesn't make any sense. So the ball hits the ground after 4 seconds. Okay, here I've graphed the entire function. This is just that parabola we've been working with. Back here, these are all those negative times that don't make any sense when Dave's still going up to the roof or standing on the roof. None of this makes any sense in our physical situation. Over here, past 4 seconds, at 4 seconds the ball hit the ground. It's now sitting on the ground. These negative heights over here don't make any sense. We won't keep those. This red section here, or orange section of the graph, is the only relevant part. This would be our domain for this real world application. Times between 0 when he lets go, up to 4 seconds when the ball hits the ground. And we can see here after 1 second we reach our maximum height of 144 feet. Okay, another classic quadratic application. All college algebra books love this problem, is the fence problem. We've got a farmer. He wants to build a fence along a river. He's got 100 feet of fencing and he wants the maximum area he can get out of his fencing. Now he's building this along a river. So here's the river, the little squigglies. He's not going to put a fence up on this fourth side. The river is the fourth side. He's only going to build 3 sides. Okay, so we've got, let's call these sides here, the ones perpendicular to the river, call those L. And then this side parallel to the river, we'll call it W. So the amount of fencing that he's actually using, he's got an L plus a W plus another L, have to add up to 100. That's how much fence he has. Area of a rectangle is just length times width. That's what we're going to try to maximize. So we get our perimeter equation. We had 2 sides of length L plus 1 side of length W. That has to add up to 100. We want to maximize the area. It's a rectangle. Area is length times width. Okay, so this is the guy we want to maximize, which means we need to write area in terms of only one variable. We've got 2 variables here. There's nothing we can do with that. I need to make one of these letters go away. Well, we'll do that by using this other piece of information here, solving this for one variable and substituting that into this area formula so that we can write area as a function of only one variable. Okay, so if perimeter is 2L plus W equals 100, I can solve that for W and get W is 100 minus 2L. Then I take that expression, 100 minus 2L, and plug it in right here to this W. So area, this is not multiplication here, this is function notation. Area as a function of length is length times width, 100 minus 2W. Distribute the L, we get area as a function. That's not A times L, that's A of L. Is 100L minus 2L squared. That's a quadratic. It's written a little weird because we get the squared on the second term instead of the first, so we've got to be careful here. A is negative 2, and B is 100, and C is 0. Okay, we want to maximize this. That means finding the vertex. Anytime you want to maximize or minimize something, you're looking for the vertex. Okay, so vertex, H, the X or L coordinate of the vertex is opposite of B over twice A. So B here, the number in front of the non-squared term, B is 100, so opposite of B would be negative 100. A is the number in front of your squared variable. So A is negative 2. Twice negative 2 is negative 4. Negative 100 over negative 4 is 25. So that's L. That's our length that maximizes the area. L is 25. Well, if L is 25, remember W is 100 minus twice L. Hey, look, we have this written right here. So if L is 25, W would be 100 minus twice 25. 100 minus 50 is 50. So our dimensions are 25 by 50. So that's how we maximize the area. We have a width of 50 feet. That was that side parallel to the river. And a length of 25 feet. That was the side perpendicular to the river. Then what would the maximum area itself be? Well, to find that maximum area, we could go back to our area formula and plug in our length. L is 25. Check that on your own. Plug 25 in here. You'll see you get 1250. Or another way, area is just length times width. Since I know both length and width now, I could just take 50 times 25, and guess what? I get 1250. So here, this orange graph is our area as a function of length. Down here, on my x-axis, I have the possible lengths. Notice that if I have a length of 0, if I build my fence all just in a line, then I would have a 100-foot fence in a line. I get no area out of that. The width would be 0, or the length is 0. Length times width is area. Or if I build my fence 50 feet long and then put right beside that another fence 50 feet long with 0 width, I would still get an area of 0. So my lengths here have to be between 0 and 50 to save some space to put some area in there. The maximum area happens right here when the length is 25, and that maximum value is 1250 square feet. Okay, that's quadratic applications. In here, we needed to know how to find the vertex. We needed to, at one point, know how to solve quadratics. So there should be some videos popping up here for solving quadratics and finding vertex. Click on those if you need more help with that.